All right, hello, welcome. Today's goal is to understand merge sort. And I'm not going to lie, this I think is one of the hardest things in all of AP Computer Science class. So when I explain it, I sometimes look like this at the end of it. So good luck. Ask me questions if it doesn't make sense. A lot of the visualization tools hopefully will help. Um, Again, you don't have to code it on the AP test. We have to kind of understand how it works. All right, so this is our third algorithm, right? So there's selection, insertion, and we're going to do merge, right? So today we're just going to talk about how it works, and then tomorrow you're going to look at the big O notation and the efficiency of it. So far, selection, insertion are n squared, and we're going to see what happens with this merge sort and figure out is it actually better or worse than the other two. Okay, so I'm going to start, just try and make it as simple as possible. All right, so I'm actually going to explain the very end of merge sort. So merge sort gets its name because you have like two lists of numbers. So at this point, the algorithms run almost to the end, but we've got a set of five sorted integers and then another set of five. All right, and then we're just going to put them in order. We're essentially going to merge these two together in order. Right, so this is kind of the merge step of merge sort. It's actually the last step, but we're just going to do one step at a time to make sense of it. So how it'll work is you have this little counter, and all we do, we know these are in order, so you're just comparing the first one that hasn't been used. So in this case, we say, okay, well, we're comparing 1 to 5, and 1 is the smaller of the two. So we're going to move down to 1, say that one's used up, and then move over the little pointer. And now we are pointing at 5 and 8 and say, okay, 5 is the smaller one, so 5 would come next. And we wipe that 5 out and say, okay, now we've used the 5, so move the pointer over now. Now we're comparing 8 and 9. The smaller of those two, anyone? 8. Yep, correct. You were right. It is 8. So 8 has been used up. Now we move the pointer over and say, okay, now we have the smallest two are 9 and 11. And it looks like, all right, 9's the smaller. So we're going to wipe that out, move the pointer over. Now it's 10 to 11, and 10 is the smaller of those two. So we write down the 10, wipe that one out, move over, right? And so it doesn't always alternate lists. It's kind of just, there might be a bunch from one list. It just kind of depends. At this point, it's 11 and 12, so the 11 comes down. So you use that one up, move our pointer, move our index over one, and now we're comparing the 12 and the 20, and so it's going to take the next two from over here, right? Because those are the smaller two. So it's going to go 12, zoop, and then move it over, compare again, 17 to 20. And so 17 is a smaller one, wipes it out. Okay, and now we know we've used up this list. And so once we've used it up, basically we know we just put, these are already in order in the other list, so they just slide down, right? So there's not really many comparisons here anymore. The 20 slides down and the 32 slides down, and boom, now we have a merged list of our 10 numbers. So that's where it gets, its name is merge sort, is it takes two little lists and merge them together. All right, so I want to give a full example now. And so the only difference is that again, the one from yesterday, previous slide was just the final step. Okay, so what really happens is you start with an array of unsorted numbers like this, and you split them. Okay, so we have 8 numbers here. So 4 of them go on this side. Oops, I did not want to do that. Sorry about that. And then 4 of them go on this side. Okay, and then from there they split again. Sorry, I gotta ungroup these. So from there, this 4 just splits these two, and then it splits these two here. Okay, and then same thing over here. We have 4 of them, so it splits it into 2 and 2. Man, why does it keep doing that? Sorry about that. These two split down. Okay, and then you keep going until you split into 1. So this is going to split again, splits it to a 9 and 2, and then 3 and a 4. And then the 1 and 0 splits until you have single elements. So this is actually a recursive method where the splitting just keeps splitting until you have single elements, and then it starts the merge process. All right, so once you have it down to single elements, what it does is it says, okay, I'm just going to sort these two, and it says, well, which one's smaller? So it pulls the 2 first and then the 9. Then it'll merge these two and say, okay, 3 and 4. All right. And now it'll merge with that pointer idea that I was talking about from the last slide. Now it'll merge these 4 together, and it'll just say, okay, which one is the smaller out of 3 and 2? Looks like it's the 2, so it'll pull that one down, move over the pointer. Now it'll say what's smaller between 9 and 3. 3 is smaller. Move over this pointer and say, okay, now between 4 and 9, we move down the 4, and then finally we move down the 9. Okay, so those 4 are now sorted. Now we go over and do the same thing on the other side. Sort these two, and then the 6 and the 9, which are already sorted, so sort them. Okay, now we got to merge these lists of 2, so we're going to use our little pointers. Indexes, I should say, maybe be a better name for these. And it'll say, okay, between 0 and 6, 0 is the smaller one. Now it's comparing 1 to 6, so 1 is the smaller one. So this list has been exhausted, so now we just bring down the other 2 in order. Okay, and now we just have to merge these 4 just like we did in the last picture. So from here, it just does the pointer thing, and it's going to pull the 0 first, comparing 0 to 2. Now it's comparing 2 to 1. 1's the smaller one. Now we're comparing 6 to 2. And so we can kind of speed mode a little bit here because we can see 2, 3, 4 are all smaller than 6. So it's just going to pull down 2, move it over. 3 is still smaller than 6. Move it over. 4 is still smaller than 6. Move it over. And finally, 6 is the smaller one, so it brings down 6. Now it compares 9 to 9. I'm not sure what it'll do here. I guess depending on the code, you'd probably bring down this 9 and then bring down the last 9. All right, now we have sorted the numbers. So the only thing that's different here is it splits them, right? The code splits it down until it's smaller and smaller arrays until you have an array of 1, and then it starts merging things back. All right. So one other thing, I guess, the only other real thing I need to demo here maybe is what happens if there's 9 numbers, right? Or an odd number of numbers, I guess, right? So we can't split it evenly. In the last example, I could split it into 4 and 4 pretty evenly at the start. This example, it's not even. So I think how it works is it just puts 4 in one and 5 in the other. So, you know, I don't know which is which. It really honestly doesn't matter. It depends on how the code is written. But it would split it here, so you have 4 and 5. Okay, and then it would start to sub-split. So here would be, we'd split these into 2 and 2, and then these would split to 1 and 1. Okay, and then same thing up here. Now we have 5. So it would probably just do like 2 in one side and 3 in the other, and then split these two. Okay, and again, in this little group, it would probably just make split it so that there's 10 and then 9, 0, and 9 in a group, and then this 0, 9 would split again, right? So that it would be groups of 1. Okay, and then it just comes back and merges them, right? So it would be the 2 and the 4 merged together, the 1 and the 12. Those were single elements that grouped into, now they're groups of 2. Sometimes I try and draw them like this. I'm going to struggle to draw this a little bit on here. Okay, so boom, it looks like that. And now it's going to put those 4 in order using the little pointer thing we talked about. So this is my best attempt to draw this. Sorry for the childish handwriting. But it pulls the 1 first, compares the 1 to the 2. Now it's comparing 2 to 12. It'll take the 2. Between 4 and 12, it'll take the 4, 12. Okay, and then over here, let's draw these awesome boxes. Awesome sauce. All right, so the 5 and the 6, pretty much already in order. Boom, boom. Then with the odd numbers here, I think the 10 just kind of gets brought down on its own. It's its own little element. And then the 0 and 9 will get merged. So boom, this gets merged. Boom, boom. Comes the 10. Okay, and now it'll merge those 3 together. So I'm going to go zoop. Doing the same pointer trick. So it'll compare the 10 to the 0 and take the 0. 10 compared to 9, take the 9. Then 10 goes here. Okay, and now I'm going to bring this down. Do this right. Bring those ones down. Okay, and now it just merges those 5 together. So there's going to be 5 spaces, blah, 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 blah. So it takes the 0, then the 5, then the 6, 9, 10. Okay, and then now it's going to merge these two together. So you'll have 9 spots. Okay, and so I'm gonna fly through this because I feel like we've done this already. So now the 0 comes first. Now we're comparing 5 to 1, 2 to 5, 4 to 5, 12 to 5. So now the 5 will get drawn. 6 and 12, take the 6, 9 compared to 12, 10 compared to 12, and then finally the 12 goes on the end. All right, so we set our 9 together. Couple questions for you. All right, so starting to talk about efficiency, there's kind of 2 things we're going to have to worry about when we have the efficiency is like how many comparisons done during the merge, right, which is kind of tricky to figure out, and then how many splits. So maybe take a minute here and see how many splits were there for these 9 numbers. Okay, so hopefully you can see that there was 8 splits, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so there's 8 splits, and I'm going to go back one and say, do you remember for this was 8 numbers. How many splits were there here? All right, and hopefully you get 7. I think if you count the number of red lines, there was 7 splits for 8 numbers. Okay, so kind of then let's see if we can generalize this. So if there were n numbers, how many splits? Okay, and hopefully you figured it out that there's just one less, n minus 1 splits, right? So you have to have a split between each number, but there's sort of 7 gaps between 8 numbers, so there's n minus 1 splits. And I think a real good activity for you at this point is, here's an example of 7 numbers being sorted using merge sort. So you can see they've done the splits already, and it looks like there's like 3 levels of splits, right, if we count them, which will matter when we start to do efficiency. So I just want to highlight that there's 3 levels of splits by the look of it. And then, so my question is, what does the rest of this look like? See if you can draw it getting merged together, and then count the number of comparisons. All right, see if you can figure that out. So pause it, and then I'll go through the answer with you. Okay, so here we go. See if Mr. Westphal can actually get this right. So here's what it looks like if you want to check your answer. All right, and so if we count the comparisons, we had to compare 38 and 27 here, so that had been 1. These two is 1, 1, and then 10 really didn't need to be compared to anything, so no comparisons there. Now when we merge, we're going to have to compare 3 to 27, and then let's see, so it would be 27 to 43, and then it'd be 38 to 43, so I think that would be 3 comparisons there. Here I think there'd just be 2, the 9 and the 10, and then the 10 and the 82 as they're getting merged. And then coming down here, I think it's like 1 comparison sort of for each number that gets merged, right? So like each time we compare, we're picking the smaller of the 2. So I think it'd be 1 compare for each number. So since there's 7 numbers here, I think there would be 6 comparisons that we would need. Think if that makes sense. So at each level, there's a decent number of comparisons, 1 for each thing you need to merge together. Okay, final things to finish this up. 1, the assignment is going to be out on Schoology, and it's just a worksheet that you probably either have to print and do your work on the printed copy, or just look at the electronic copy and do your work on a notebook. That might be another way to do it, and then you'll have to take a picture of it and turn it in. And I know that's a little goofy, but I couldn't think of an easier way to do it. And if you need help with that process, just email it to me. Okay, and then the final thing I have to help you understand merge sort here is that I'll leave you a link to this site again. That's kind of just visualizing it here for you. And I do think this is really useful. So if you want to like see what's happening again in merge sort, I strongly encourage you to kind of watch this, play around with it. You can increase the speed, decrease the speed, but that'll hopefully give you a better sense of how merge sort works. So I'll post a link to this again if you want to look at it. All right. Thank you. That's